Hello and welcome to the walking talking topic on bounds and estimations, question number 6 with me, Mr. Barton. Now this is a beautiful question if you're sad and into maths like me, because this fuses together the topic of bounds and estimations with a lovely bit of perimeter and even some circles chucked in for good measure. And there's bags of marks available for this, 5 lovely marks, so let's see if we can get them all. We've got Heather, and she for some reason wants to attach tape around the rim of the bases of 2 decorative displays. In each case, the tape attached does not overlap itself. One of the bases is circular with a diameter of 50. I'm going to use my amazing artistic skills to draw that now. Now I'd love my pen to work. There we go, and that's got a diameter of 50. And the other is a rectangle, and that rectangle is 45 centimetres long and 32 centimetres wide. All above measurements are correct to the nearest centimetre. Show that it is not certain that the length of tape around the circular base will be longer than the length of tape around the rectangular base. So we've got an interesting bounds question here where we've got to almost think kind of worst case scenario. So we've got to show that it is not certain that this circular base will actually be longer than the rectangular base. So let's try and make the circular base as small as possible. And let's try and make the rectangular base as long as possible. And if we can show that this one here could possibly be longer than this one here, then we've solved the problem. Okay, so let's try and make the circular base as small as possible. And remember, it's the perimeter, or when it comes to circles, the circumference. So the circumference of a circle is equal to pi times by the diameter. Well, how are we going to make that 50 as small as it possibly can be? Well, it's 50 to the nearest centimetre. So that is 50. And how big could it go? Well, it could be 50.5. Any bigger than that, it's going to go up to 51. Or it could be 49.5. Any smaller than that, it's going to go down to 49. So we want it as small as possible, and we're times in, so I'm going to use my 49.5. So my circumference, the kind of lower bound of my circumference, is 49.5 times by pi, or pi times by 49.5. Let's bang that into the calculator. 49.5 times by my pi, and that calculator helpfully tells me that's 49.5 times pi. But if I press my SD button, I get 155.508 blah blah blah, and that's going to be centimetres because it is a length. Now what about my my rectangular thing? I want to make this as long as possible. Well, I've got lengths of 32 and 45, and using the same principle, you can very quickly see that the longest 32 can be is 32.5, and the smallest, the shortest, sorry, it can be is 31.5. And likewise with 45, if it's rounded to the nearest centimetre, that could be 45.5, or it could be 44.5. Now I want that to be as long as possible, so I'm going to use the upper bounds this time of both of them. So we're going to need a total perimeter, because I want to know how much ribbon goes all the way around. So for perimeter, I'm going to start on my bottom a bit, so I'm going to go for 45.5. Then let's go up the side, plus a 32.5. Each time I'm taking the upper bound. Then I'm going to have another 45.5, and then I'm going to have another 32.5 to get all the way around. And if I add those up, I'm crossing my fingers and hoping that they could be longer than that one. And then I'm laughing. So let's have a look. 45.5 plus my 32.5 plus my 45.5 plus my 32.5. Total is 156 centimetres. And I'm just going to show off now. I'm just going to write down. I might do this actually. 156 is greater than 155.508. Therefore, and excuse my writing, it is possible that rectangular base is longer. Help yourself to 5 nice marks.